Hi guys, my name is Trevor Sullivan and welcome to another CBT Nuggets skill where we are going to continue learning about Kubernetes. And in this particular skill, we're going to dive into the topic of networking so that you can understand how networking is applied inside of a Kubernetes environment on the nodes that are running your cluster, the master and the worker nodes, as well as how pods are able to get IP addresses and how network traffic can be distributed across the pods that are deployed into your Kubernetes cluster. So I've put together a little diagram here that is going to help us understand how some of these different things work. And I'm going to be using the Amazon Web Services cloud platform, in particular the Amazon Elastic Kubernetes Service, EKS, in order to kind of demonstrate how these concepts work. However, these concepts really are more general networking concepts, and they should apply to pretty much any network environment that you're working inside of. So for starters here, we've got a cluster, and the cluster, as we just mentioned, is made up of master nodes as well as worker nodes. And the master nodes are the nodes that are running the controller manager, the scheduler component that's responsible for placing pods onto worker nodes and things like that. And in most cloud environments like EKS or Google Kubernetes Engine, GKE, or the Microsoft Azure Kubernetes Service, AKS, most of those major cloud vendors are going to kind of abstract those master nodes from you, so you don't really have direct access to them. You don't need to SSH into them, you don't need to install software on them, you don't need to patch them or monitor them. They basically just get spun up by the managed service from that cloud vendor, and then you can join your own worker nodes to the master nodes that are running your Kubernetes cluster here. So then we've also got these Kubernetes worker nodes, and in order for all of these worker nodes to communicate with each other, as well as to be able to communicate with the master nodes in order to receive instructions from them, the worker nodes are also going to need to have IP addresses on the network that they belong to. So in Amazon Web Services, that network, that software-defined network in the cloud, is just known as a VPC, or Virtual Private Cloud. Now, the Virtual Private Cloud is going to have a CIDR block, and the CIDR block is basically just the IP allocation for that particular virtual network, and then they'll be able to get IP addresses from that CIDR block. So in order to manage the worker nodes themselves, if you want to do any troubleshooting or monitoring or anything like that, you're of course going to need to have a network interface here with an IP address allocated to that particular node. And that's how that node is going to communicate with other devices on the network. However, your pods are also going to need to have IP addresses as well. So when you as an administrator deploy a pod out to your cluster here, that pod needs to be able to communicate with other resources on the network. And the way that that happens is through what's known as a container network interface. So when you create a pod, that pod is actually going to get an IP address on the virtual network. So if we take this little network interface right here and allocate that to the pod, that pod would then have the IP address of 10.5.5.187. And so that pod is then able to communicate with other devices that are on that same network. And that pod is also able to get out to the internet as well through something known as an internet gateway. So if that pod needs to communicate with any external services out on the internet, then any of these devices actually on the network would then be able to go through this internet gateway and reach out to resources that are on the internet. That's how things kind of work from a pod networking perspective. The Kubernetes cluster has the container network interface known as the Amazon VPC CNI, and that's what allows your pods to get IP addresses on the network. Now, the Kubernetes cluster as well has something known as a cluster network. And the cluster network is essentially a CIDR block of IP addresses that pods can obtain off of the cluster network instead of directly on the VPC or software defined network using the AWS VPC CNI. And so in a standard Kubernetes cluster, if you were to just spin up your own cluster using kubeadm, for example, then your pods would actually get IP addresses on this cluster network instead. And that's basically an internal network to the Kubernetes cluster that is going to dole out IP addresses to the containers that are being spun up by these pods. Now, if you have a service that's made up of many different pods, so maybe your service has more than one pod, then what you're going to do is actually create what's known as a service controller. And the service controller itself is actually going to get an IP address off of this cluster network here. So if we were to create a service controller, it would get this internal IP address on this cluster network here, and then the service controller would actually point to the pods that actually have their own network interfaces over here on the Amazon VPC. Now, what's nice about the service controller is that it acts as sort of a load balancer, and the service controller will basically allow you to load balance traffic across multiple pods here. So if I was to actually just take this little box here and kind of put it behind these pods, the service controller allows me to point to more than one pod. And this is a really useful concept because if something were to happen to one of these pods, where maybe the application that's running inside of a container were to crash, then the service controller could actually route traffic to the other good pods that are members of that particular service controller. So the service controller is going to basically expose itself on the cluster network, but it's going to point to pods that are actually getting IP addresses on your software-defined network in the Amazon VPC. So that kind of presents us with a new challenge, which is how do we get the cluster services exposed to the outside? And we have a couple of options for that. And one of those options is to use something known as a cloud load balancer. So the service controller itself is going to load balance across multiple pods, but that's only internal traffic to the cluster. If we actually want to load balance traffic and expose it externally, then we need to create a cloud load balancer and then put that in front of the service controller. So I'm actually going to bring that load balancer right down over here, and that load balancer is going to point to our service controller, and then if any of the pods were to die inside of this service controller, then the load balancer will simply be able to route traffic to the good pods that are still up and running inside of this service controller that we have here. So the service controller can either expose itself on the cluster network, or it can expose itself through a load balancer that is provisioned into your AWS account or whatever cloud platform you're using. It's basically a separate cloud resource that gets provisioned, and then it will be configured to forward traffic from the internet over to your service controller. That's kind of how things work from the service controller perspective. Now, in addition to exposing a service controller directly on the cluster network internally, as well as exposing it through an external cloud load balancer, there's actually one other technique that you can use to expose a service. So let's get rid of our load balancer here for now. And basically, the other option that you have for exposing this service into your environment is to do something called a node port exposure. And so what that would basically do is it would take a port on all of your worker nodes here, and it will forward traffic to the pods that are supporting that service controller. So say, for example, that we have an application like Nginx, basically just a web server that's running inside of these pods on, let's say, port 80. Let me just get a copy of this text box here, and we'll say port 80. And so we've got on both of these pods here, we have Nginx listening on port 80. And if we wanted to expose that to our network environment here, what we can do is on the service controller here, we can create something called a node port configuration, and that will take traffic from a particular port on all of our worker nodes in our cluster, and it will forward that traffic to port 80 running inside of these pods here. So for example, on our worker nodes over here, maybe we want to map port, I don't know, 34,500 to port 80. So what we'll do is basically take that port and expose it through the service controller on all of the network interfaces that our nodes have, and then we could actually hit any one of these nodes in our cluster on port 34,500, and that would then forward the traffic over to port 80 running in these pods here. So those are kind of the three options that you really have. You have exposing on the cluster IP internally, which is good for any services that don't need to be exposed outside of the cluster. That could hold true for something like a database service. If you're running a database server inside of a pod and only a limited number of services need access to that database, you could run that database as a service and expose it on the cluster network, but not expose it through a load balancer or through a node port. Whereas if you're running an application that does need to be accessed by external users, then you'll probably want to use either the node port or use an external load balancer to expose that service to your users, depending on where they're coming in from. If they're coming in from directly across the internet, you'll almost certainly want to use the load balancer. But if you have other internal services that are maybe running side by side with your Kubernetes cluster on the same software-defined network in the cloud, then you might be able to actually get away with using a node port exposure that way. So that's kind of how things work from a conceptual level anyways. So we've got our pods getting network interfaces right here on our VPC. We've got the options to expose our service through node ports, load balancers, and on the cluster network up here. And then basically we can explore how these actually work in practice by creating some pods, creating a service, and then exposing that service using some of these different techniques. I hope this has been informative for you, and I'd like to thank you for viewing.